good evening, guys. This is your pre-lab lecture for the titration of acids and bases. This is going to be your take-home lab for tonight. So what I'm going to do is go through the pre-lab lecture, tell you how to go about doing the calculations and using the data that I provided you on the Word document. All right, so this is another titration process, but this is going to be a little different than what you were originally going to do in the past experiment and what was supposed to be done tonight. So what the difference is that you're going to be standardizing sodium hydroxide, and then you're going to be figuring out the concentration of an unknown solution of HCl. And so the first part is to standardize the sodium hydroxide. Now what standardize means is that you are going to take a known factor to figure out the unknown. Okay, so then standardize sodium hydroxide. Now what we're going to use is KHP. KHP is not potassium hydrogen phosphorus, but it's potassium hydrogen phthalate. I provided you the bottle on Moodle so you can see what the formula weight is and also the formula of that compound. So now what we're going to do here is this is an acid-base reaction. And so now sodium hydroxide is a base. Sodium hydroxide will react with the KHP. Now if you look at the first page, you'll see the structure of KHP. All right, so you can, then the formula is on the bottle. Be reminded of that, okay? So I'm just going to abbreviate it as KHP on here for simplicity. Now KHP is an acidic compound because it has a carboxylic acid on it. And so what will happen is that this will be a neutralization reaction. So this acid is going to react with this base and it's going to form the conjugate. So you're going to form water plus the Kp with a minus charge because the hydrogen is going to come off. All right, so the hydrogen itself is now formed water over here as a product. So now what you're going to use here is you're going to use the molar ratio. Now this equation is already balanced. It's 1 to 1 to 1 to 1. But what's important here is that we need to understand the reactants part. All right, so now what you're going to use is you're going to know the mass of the KHP. And so what you're going to do is you're going to take the mass of KHP and you're going to convert that into moles of KHP. Now again, that's why I provided you the bottle so you can look at the formula and know what the molar mass of that compound is. So remember, if you want to go from mass to moles, you're going to divide by the molecular weight of it. All right, so then what you'll do is you'll take the moles of the KHP, you'll use the Molar ratio, and you'll solve for the moles of sodium hydroxide. Now, to figure out the molarity of the sodium hydroxide, that's our goal here. What you're going to do is you're going to take the moles of sodium hydroxide, and you're going to divide it by the volume of sodium hydroxide used. Now this is what's going to come from the titration. So to get that number there, you're going to use the data table that I provided you in the Word document. All right, which you can see here in trial 1. Now there are 2 trials for this, so what you'll do is you'll calculate the molarity for trial 1, and you'll calculate the molarity using trial 2 and you'll average those 2 out. All right, so you only need 1 molarity here, so you only need to fill in one of those spaces there. All right, now so the way that we figure out the volume of HCl is that we used the burette. All right, and so with the burette we had an initial volume of the sodium hydroxide. We did the reaction, and then we ended up with a final volume. So to figure out the volume used, you're going to take the final volume, you're going to subtract it from the initial volume, and that's the value that goes here. But do be reminded that your volume is in milliliters, and for molarity, you have to convert that into liters. So that's something you need to make sure you do before you do that calculation. Now, in the second part, you're going to be figuring out the unknown concentration of HCl. All right, so HCl is hydrochloric acid. And so we're going to still, again, use the burette with sodium hydroxide, but this time what we're going to do is we're going to use the HCl on the bottom. And so if you follow the procedure, you'll see that you take just 2 mils of the HCl and you dilute it to 75 mmol and then you titrate it. Now this again is a neutralization reaction where you're going to take sodium hydroxide, you're going to react it with the HCl. All right, so now this is acidic, this is an acid, this is a base, neutralization, forms water plus the salt, NaCl. So balance this equation out. It's pretty simple. It's 1 to 1 to 1 to 1. So again, we're going to go back to the fact that we're going to use the Molar Ratio, because our goal here is to figure out the molarity of the HCl. So what we just did in the previous part is we figured out the molarity of the NaOH. And so again, in this experiment here, you're going to determine the volume of sodium hydroxide used. And so now you're going to take the molarity. So this is the difference between the last one, is that the last one we used the mass of KHP to figure out the moles. Here we're going to use the volume of sodium hydroxide to figure out the moles of sodium hydroxide. Okay? And so to do this, what you're going to have to use is the molarity. And so what we're going to do is we are going to multiply by the molarity of sodium hydroxide. So once we figure out the moles of sodium hydroxide, we can then figure out the moles of HCl. All right, so figure out the moles of HCl. So again, that's the Molar Ratio. And then finally, to figure out the molarity of your HCl, what you'll do is you'll take the moles of HCl divided by the volume of HCl used. Okay, so that goes back over here to the beginning where, and you'll see it in the table that I provided you with the data that was collected, that we only used 2 milliliters of the HCl. So make sure that you convert that 2 milliliters into liters. And so always make sure you do that for each, when you determine molarity, always convert your milliliters into liters. So now that being said, so I want you guys to use the data that provided you on Moodle, and I want you to determine the molarity of NaOH by the standardization process, and then also determine the molarity of the HCl. And if you notice that in the paper it says molarity of acetic acid, cross off acetic acid and write HCl in place of that. And so there are those post-lab questions that you'll also need to complete. So make sure you complete both those pages. All right, this lab will be due on Tuesday at the beginning of lecture. So if you guys have any questions, please make sure you email me. All right, thanks.